is open up your exercise books. We're going to move on to the next exercise, and it's 14I. The title, if you look in your textbook, the title is called Transformations of these graphs, but I think a better word is translations, because in the next two exercises, we're going to see how our graph of sine and cosine translates horizontally. So translation just means a direct shift. In this exercise, it's about horizontal translations, and in the next exercise, it's about vertical translations. As you're writing the title down into your book, I've placed a question up here, and this graph has been shifted, and the question is, which way is it being shifted? Keep it to yourself for the moment. If you'd like, you can confirm your answer with the person next to you, and make sure you agree with the person next to you. Might be sketch these. Sorry. Replace attention. Should I agree.
You wash and dry. I can't say, I've never come to school.
Please excuse this interruption. There are a number of late students. Could you please accept them into class and remark your roll? They were all getting ready because it's casual dress day. Thank God we have uniform most days. Thanks, everyone.
Okay, so I'm going to place this general formula for a sine graph here, and hopefully that will help you make your decision. There's this translation described by h, only fits in these brackets, and there's a translation by k if you add a constant at the end. Okay, so I'm going to ask you to consider your answer again, and raise your hand if you think the answer is A, it gets shifted down. Okay, raise your hand if you think it's B, it gets shifted up. C, if it gets shifted to the right. Okay, that's interesting. Oscar, why do you think it gets shifted to the right?
Because in previous formulas, whenever it's in the brackets, it always got shifted to the right if it was negative, and shifted to the left if it was positive.
Okay, great. So you're linking it to all of our previous functions, and that's exactly the case. So it does get shifted to the right, which means your original graph of y equals sine x is going to make this just a bit bigger so you can all see. If I sketch the graph of x minus pi on 6, we should see that blue graph shifted just a bit further towards the right. And the amount it's being shifted is this value. Okay? So that's the key idea. I'm going to close the projector now and we'll take down an example. So we'll work through an example of how to sketch a graph like that. So this is EG1. Sketch y equals 2 sine of 2 times x minus pi on 4. So this example not only has a horizontal translation, but also a vertical, but also a dilation from the x-axis as well as a dilation from the y-axis. So we want to sketch this, and the domain they give us is showing one full cycle. Okay, just one cycle. Now in the past, with all the examples that we've done, we've needed to find the period as well as the amplitude. So let's read off this graph. What's the amplitude of this graph? 2. Okay, and it's 2. Period. Period is 2 pi divided by the coefficient of x. So right now the coefficient of x sits outside the bracket, so it's 2 pi on 2, which means the period is pi. Okay, amplitude and period. Now, we need to understand that because our graph has been shifted by pi on 4 units, our starting x value is different. So keep in mind, if you'd like to draw a basic sketch of a sine graph looks like this. But your sine graph in your question has been shifted to the right, which means your starting x value has been shifted as well. How much has your x been shifted? To the right by? Okay, so this is very important. Write this down. Starting x is now pi on 4 instead of 0. And lastly, we write our scale factor. Our scale factor helps us find our important points. So our scale factor is our period multiplied by a quarter, which is pi on 4. And this will be enough for us to begin sketching our graph. So we're going to make an axis with x and y. Our amplitude goes up to 2 from -2. And our period is pi, but it starts from the x value of pi and 4. It doesn't start from 0. So the first value we're going to label on our x-axis is pi on 4. So it starts at pi on 4 instead of 0. At this point, we can use our scale factor to list the other important points on our graph, and our scale factor is pi on 4. So we're going to add pi on 4 onto our starting x value, which means we're going to have 2 pi on 4, 3 pi on 4, 4 pi on 4, and lastly, 5 pi on 4. And notice that for one full cycle, which is 4 scale factors, we still complete a period of pi. That was the period that was given from the equation. So this is a length of 1 period. Now we can begin putting down our important points. Knowing that with sine, we start with 0 at our starting x value. Then it makes a maximum. Then it goes to 0. Then it makes a minimum. Then it goes to 0 again. Keeping in mind that this graph hasn't been reflected upside down, so it should go to the top first. And then we can make a curve by joining up our points. Okay, and that's it. You've sketched a graph that's had a horizontal translation. Okay, we're going to do a similar example now. So please copy this down. EG2. Sketch f such that the domain 0 to pi maps to R such that the function is 2 sine of 2 times x minus pi on 4. Notice that the equation is the same as the previous question, but this time, instead of showing one full cycle, they give us the domain. The graph has to exist between those x values. Okay, so we go through all of our previous steps. I know you've already found this in the previous question, but let's just write them down again. The amplitude is 2. The period is 2 pi on 2, which is pi. The starting x value is no longer pi on 4, because our domain, they've stated for it to have to start from 0. X starts from 0 and it ends at pi. Starting x is 0. Okay, and lastly, we'll write down our scale factor as well. Scale factor, which is pi multiplied by pi on 4, that gives, pi multiplied by 1 on 4, that gives pi on 4. I've intentionally left some space at the side, but if you don't have space at the side, make sure you leave some space and draw your graph a bit further below because we need to write down some more information. So we start with our graph with x and y. We have our amplitude, which goes to 2 and negative 2. Now, knowing that we have a horizontal translation, our sine, the y-coordinate of that sine graph, can't start at 0 anymore. It's been shifted across. So where that x-intercept is, now isn't at the origin. So at the origin, your y value isn't going to be 0. So we need to calculate that y value. When x is 0, what is y? Okay, we're going to make that calculation now. So when x is 0, we sub that in. In function notation, we replace x with 0 and we evaluate this expression. So we get 2 sine of 2 times 0 minus pi on 4. So when x is 0, y is this thing. Now that simplifies to 2 sine of 2 times negative pi on 4, which is 2 sine of negative pi on 2.
Can we put the negative outside the bracket?
Outside the sign?
Yeah.
Yes, that's exactly what I'm going to do. Now that pi on 2, I got that from taking 2 and dividing by 4, and the 2 and the 4 cancels out up to a half. And now by your symmetry relationship for a sine, if there's a negative inside the bracket, you can bring it out to the front, and it only works with sine and tan, but not with cos. So it becomes negative 2 of sine pi halves. And at this point, we evaluate our exact value of sine of pi halves. You either use your table or draw a unit circle, but pi halves, we're at 90 degrees. So we're at the top of our circle. What's the y-coordinate there?
Do I have to divide it by 90?
Sorry?
What happens if 2 outside of the part? Do we
Yes, we
divide it?
multiply it by negative 2 afterwards.
Okay.
But first we figure out sine of pi halves. So sine of pi halves turns out to be 1 because the y-coordinate is 1 at 90 degrees. So it'll be negative 2 times 1, which is negative 2. In other words, when x is 0, the y-coordinate is negative 2. Your graph starts from negative 2. It starts from down there. Now we can do the same thing for f of pi. That's the other endpoint. But we can do that in a moment. We're going to label this point, that's the starting value, and we're going to label our scale factors starting from x is 0. So we have pi on 4, 2 pi on 4, 3 pi on 4, then 4 pi on 4. 4 pi on 4 would be the end point of our domain. And at this point, we can start sketching our graph. Now, keeping in mind, our scale factor lists all of our important points. So where they hit 0, where they hit their maximum, and where they hit their minimum. So we started off with our minimum, so the next point should be at 0, then the next point should be the maximum, then 0, then another minimum. So let's sketch this in. And it kind of looks like an inverted cosine graph. You'll learn later on that sines and cosines are related by 90 degrees. Okay, now this here has said that the end point of our domain ended at negative 2, and we can confirm that. We can confirm that by subbing in f of the other endpoint pi into our equation. So let's confirm that at pi, we get -2. So we sub in pi, which is our x value, and we evaluate this. So sine of 2 times 3 pi on 4, which is 2 times sine of 3 pi on 2. And at this point, we can evaluate that exact value. At 3 pi on 2, we're at the bottom of our circle, and the y-coordinate at the bottom of our circle is -1. So we get 2 times -1, which is -2. So that's confirmed that at our other endpoint, when x is pi, the y-coordinate is -2. That's why the graph goes down to the bottom again. Okay, so there's two types of questions that you'll do. One question is where you just show one full cycle, and to show one full cycle, just find the starting x value, and then make your graph and label the key points at each of the scale factors. That's for one full cycle. However, if they want you to sketch the graph within a specified domain, then you have to figure out the coordinates at each end of the domain and sketch your graph accordingly to the scale factor. We're going to do two more examples, and then I'll let you do some work today. So this example would be example 3. Sketch y equals √2 sine of 2 times theta take away pi thirds. And we should specify for which region we should sketch it for, and it's for showing one full cycle. So this is going to be like example 1. To do this, we need to find our amplitude. What's our amplitude for this question? Yeah, √2, that's the number up front. Our period, 2 pi on 2, great, which simplifies the pi. And then our scale factor. At this point, you don't always have to write pi times 1 on 4. You can just write the quarter of that value, pi on 4. Okay, and lastly, knowing that we have a horizontal translation, we should write down our starting x. Okay, starting x value. Would that be negative pi thirds? Or positive pi thirds? Negative or positive pi thirds? Nikki, what do you think?
Positive.
Positive? Great, because you've identified that it goes in the other direction. So it starts at positive pi thirds. Now, what I'm going to do here is I'm going to convert the scale factor and the starting x value to have the same common denominator. And the reason for making it have the same common denominator is later on when we label the values on our x-axis, then it'll be much easier to read if they've got the same common denominator. So at this point, I'm going to turn this into a common denominator of 12. So that would be 4 pi and 12. And our scale factor is 3 pi and 12. Still the same numbers, but it's easier to label on an axis. So key point, common denominator. Okay, so let's sketch this graph now for x and y. Knowing that our starting x value starts from 4 pi and 12. And our scale factor increases by 3 pi and 12 each time. So I'm going to label another, how many more? 3 more. 3 more units on our x coordinate. So the next value would be 4 pi and 12 plus 3 pi and 12, which is 7 pi and 12. Then 10 pi and 12. Then 13 pi and 12. Let me make sure that's not 1, 2, I think I need one more. 16 pi and 12. Okay, and at this point, we begin to sketch our graph. So we've got a sine graph. It's not being reflected, so it should go upwards to our maximum from its starting x value. So I'm going to put those place values in. Sorry, I haven't labelled the amplitude, so it's root 2 and negative root 2. So it starts from 0, goes to the top, and back to 0, to the bottom, and back to 0 again. So this is what we should see. Okay, and that's one full cycle. At this point, I've just noticed a mistake with my labeling. The graph is correct, but there's a wrong label. There's something labeled incorrectly on my graph.
The negative root 2.
No, the negative root 2 is correct. Katie,
16
do you know?
No.
Okay. It's about the axes, how I've labeled my axes.
I'm confused.
So our axes are labelled x and y, which we should, right? Cool, do you know? It's theta, right? We're graphing it in terms of theta, not x. It's one small thing, but that theta means our horizontal axes should be theta instead of x. That's my mistake, sorry about that. Okay, now last one. So this is example 4.
Are we going to have a cost?
Yep, we're going to do a cos graph.
Thank God.
So we're going to sketch
Starting to get worried about
y equals 2 cos of 3 times theta plus pi and 4. Once again, it's theta, so we're going to label our graph with theta instead of x.
there.
In fact, with this question, we should have written starting theta value instead of starting theta value. Okay, so we want to do this for one full cycle, showing one full cycle. Okay, with this, we have the amplitude, which is 2, the period, which is 2 pi on 3, because we divide that by 3 to get our period, and the starting x, and
Theta.
yeah, starting theta value, great, negative pi and 4, goes the other way. We also need our scale factor, so to do that, scale factor would be our period multiplied by a quarter. So it's 2 pi on 3 times 1/4. And if I cancel out the 2 and the 4, I just get pi on 6. Because you get 3 times 2. 6. And at this point, I'm going to turn my starting theta value and my scale factor to have the same common denominator. They'll have the same denominator, so when I label it on the graph, it's easy to see how far I'm going across. So as common denominators, the starting theta value would be negative 3 pi on 12, and the scale factor would be 2 pi on 12. In fact, we're going to extend the theta axis a bit more to the negative side because it does start from negative 3 volts. So we have negative 3/12. Then our scale factor says we're going to increase that by 2 pi on 12 each time. So my next value is going to be a bit closer. So this would be negative 2 pi and 12. Is that right? No.
It's going up by pi and 6.
It's going up by pi and 6. So it's going up by 2 pi and 12. So negative 3 pi and 12 plus another 2 pi and 12 should be just negative 1 pi and 12. So in other words, negative pi and 12. Then I go another 2 pi and 12, which gives us positive pi and 12. Then another 2 pi and 12, so that gives us 3 pi and 12. And lastly, one more, that will give us 5 pi and 12. Just realised that I've got too much in the positive region and not enough in the negative region. And I should have noticed that by looking at our starting theta value.
That's alright.
Okay, so this is a cos graph. Whenever I do a graph, I always make sure I know what the shape is. Knowing that there's no reflection, it should start from its maximum, then the minimum, then back to the maximum. So here, I start from my maximum value. It'll go to my 0, then the minimum, 0, and back to the maximum. Then we're going to join those points up with a curve. Okay, and that would be your graph in that question. Now I'm going to show something that wasn't on these notes. If you'd like to copy it down, I'll leave it up to you. But this would be like example 5. It's not on the notes that are available online. It's not about sketching the graph, but it's about when the graph looks different. So find the amp, period, and translation of y equals 4 sine, negative 4 sine of 2x plus pi on 3. They just want us to find the amplitude, period, and translation. Okay, what's the amplitude of this equation? Amplitude. 4. Can't be negative. The amplitude is just the amount that your graph deviates from its central value. So the amplitude would be positive 4. But when you sketch the graph, you need to understand that it starts by going downwards instead of going upwards because there's a reflection. Okay, the period. The period and the translation, you need to be very careful at this point. The period is always going to be the coefficient of x. It's going to be related to the coefficient of x. So in this case, the coefficient of x is 2. In that case, our period, which follows the formula 2 pi on n, it's 2 pi on 2, which is pi. So one full cycle takes place in an angle of pi. The translation is not pi on 3. It's pi on 6. How do you know, Pung? Take out the 2. So it looks like all of your other graphs. Look at all your other graphs. The coefficient of x is always taken out. It's always taken out, and the theta or x value inside, it always is alone with your horizontal translation. So whenever you decide on what the translation is, you need to take out the coefficient of x. So this equation you can do the same as negative 4 sine of 2 multiplied by x plus pi on 6. Okay. Be very careful at this point because x must not have a coefficient other than 1. So at this point, you know what the translation is. The translation would be pi on 6 units. In which direction? That would be to the left.